Hello, my name is Lydia, and I will be explaining the process of ventilation and spirometry. So what is ventilation? Ventilation is the mechanical process that creates pressure changes in the lungs to draw air in and force air out. So in lamest terms, this is breathing. The respiratory system is involved in ventilation. What we're going to focus on the most would be the thoracic cavity and the lungs. To better understand ventilation, you need to be familiar with the anatomy of the thoracic cavity, lungs, and muscles. The diagram depiction shows the thoracic wall, which contains the external and internal intercostal muscles. As you make your way inward, you have the parietal pleura, which is the outermost membrane, which is attached to the inner surface of the thoracic cavity. The membrane that encases both lungs is called the visceral pleura. In between the visceral pleura and the parietal pleura is a space. This space is referred to as the pleural cavity. The diaphragm is located below the lungs and is a key component in ventilation. To understand ventilation, you need to understand that there are pressure gradients between the lungs and the atmosphere. So, atmospheric pressure, or PATM, is the pressure of the air outside the body. Intra-alveolar pressure, also known as intrapulmonary pressure, or PPUL, is the pressure inside the alveoli of the lungs. And intrapleural pressure is the pressure within the pleural cavity. These three pressures are responsible for pulmonary ventilation. Atmospheric pressure is measured at 760 millimeters of mercury. It is at equilibrium with the intrapulmonary pressure, also at 760 millimeters of mercury. Boyle's law plays a huge role in ventilation. Boyle's law states that pressure and volume have an inverse relationship. So, as pressure goes up, volume goes down, and as pressure goes down, volume goes up. Now that you understand the anatomy, pressure relationships in accordance with Boyle's law, I can start explaining ventilation. Ventilation is divided into two processes. One, inspiration, or what we call inhalation, and two, expiration, or what we call exhaling. Inspiration can be broken down further into two subcategories. Quiet inspiration, which you do at rest, just like you're doing now while watching this presentation. Quiet inspiration, it uses external intercostal muscles and the diaphragm. The second category of inspiration is forced inspiration, which is an active process. It uses the diaphragm, the pectoralis minor muscle, and the external intercostal muscles. In inspiration, the external intercostal muscles contract. This contraction pulls the ribs up and outward, expanding the thoracic cavity. The diaphragm also contracts, causing it to be pulled downward, again allowing the thoracic cavity to expand some more. Also, the sternum is pushed out and up. All of these things cause the thoracic cavity to expand, which means it would have increased volume. Because the thoracic cavity has more volume, this causes the lungs to also want to expand. The visceral pleura will expand and get closer to the parietal pleura, increasing the volume in the lungs as well. So remember Boyle's law? It stated that pressure and volume are inversely related. Well, since the volume of the thoracic cavity increased, the interpleural and intrapulmonary pressures will decrease. This decrease in intrapulmonary pressure in the lungs disturbs the equilibrium that it had with the atmospheric pressure. Now, the intrapulmonary pressure is lower than the atmospheric pressure. Here, diffusion comes into play. Air will go from high pressure concentration to low pressure concentration. So, because the atmospheric pressure is high, it will cause air to rush into the low pressure lungs. Air will stop coming in once that interpulmonary pressure reaches equilibrium with the atmospheric pressure again. So let's recap. Inhalation. The intercostal muscles relax, the external intercostal muscles contract, causing the rib cage to move upwards and outwards. Diaphragm contracts and flattens. Volume of the thoracic cavity increases. Pressure in the alveoli decreases, and air moves in. Expiration also has two subcategories: quiet expiration and forced expiration. Quiet expiration is a passive process. Technically, it uses no muscles. It's more dependent on the elasticity of the lungs rather than on muscles. The elasticity is defined as the resist to stretch. Like a rubber band that is being stretched, it wants to recoil back. Forced expiration is an active process. It's a forceful pushing of air out. It uses the abdominal muscles and internal intercostal muscles. In expiration, stretch receptors of the lungs signal the medulla to shut down the ventricle respiratory group, or the VRG, which inhibits the presynaptic neurons of the phrenic nerve, which controls the diaphragm. And it also inhibits the external intercostal nerves. When the diaphragm relaxes, it comes back up towards the lungs, which decreases the volume of the thoracic cavity. The chest wall recoils again, giving the thoracic cavity less volume. The visceral and parietal pleura also recoil. All these things give the thoracic cavity less volume. And again, according to Boyle's law, less volume equals higher pressure. The increase in intrapulmonary pressure in the lungs disturbs the equilibrium relationship it has with the atmospheric pressure. Now that the intrapulmonary pressure is higher than the atmospheric pressure, via diffusion, air will flow from the high pressure concentration to low pressure concentration, as it did before. So the air will flow out of the lungs and out of the body until it reaches equilibrium again with the atmospheric pressure. So now to recap exhalation, the internal intercostal muscles contract. The external intercostal muscles relax. Because of that, the rib cages move downwards and inwards. The diaphragm relaxes and pushes back up into the lungs, causing the volume of the thoracic cavity to decrease, which increases the pressure in the alveoli, and air moves out. Some factors that influence ventilation are airway resistance, alveolar surface tension, thoracic wall compliance, and lung compliance. So let's talk about volumes. So ventilation or breathing has a tidal volume, or TV, of 500 mLs as you're breathing in, and 500 mLs as you're breathing out. So remember that this is the amount of air inhaled and exhaled with each breath under resting conditions. This is what's called your tidal volume. Inspiratory reserve volume, or IRV, pertains to the amount of air that you inhale if you did so forcefully. So if you took a longer, more forceful inhale, like that. The ERV, or expiratory reserve volume, pertains to the amount of air you would forcefully exhale. For example, like when you're trying to blow up a balloon. So the residual volume, or RV, pertains to the amount of air remaining in the lungs. So the lungs will always have air in them even after you exhale. They cannot completely be out of air, because if they did so, they would collapse. So there's always some amount of air still in the lungs. So this brings me into spirometry. Spirometry is a diagnostic test. It attempts to measure the lung volume and rate at which gas moves into and out of the lungs. So to be more specific, it's a pulmonary functioning test. It uses an apparatus called a spirometer, and the spirometer measures the volume of air inhaled and exhaled by the lungs. So why is this done? Well, it's a diagnostic test. So it diagnoses certain types of lung diseases, such as asthma and bronchitis and emphysema. I hope this presentation was informative. And here are my references. And I'll see you guys next time.